Hello everyone, we are going to be learning about transformations of graphs. This is when a graph is transformed in some way. We're going to be learning about different types of transformations, translations, reflections, and dilations. The first one we're going to learn about are translations. This is when you take a graph and you just slide it to a different location on the graph. So it doesn't change size, it just changes location. Reflections are when a graph is flipped. So if your graph is right side up, it might be flipped upside down. Or if it was already upside down, it might be flipped right side up. And then dilations are when the graph changes size. So maybe the graph gets wider or the graph gets more narrow. But that's what transformations are, and we're specifically going to be talking about translations, reflections, and dilations. So the first transformation we're going to be talking about are translations. So if we have a parabola, this orange parabola here, which is the equation y is equal to x squared. If you want to move that orange parabola up, what you would do is you would add a number onto the end of your equation. If you wanted to move it down, you would subtract a number on the end of your equation. So those would be vertical translations up and down. If you wanted to move that orange parabola towards the left side, what you would do is you would subtract a negative number, which is basically the same as adding a number on to your function, but not on the end of your function. It would be within your function. And then same with the horizontal translation to the right, you would subtract a positive number from your function. So, for example, we're going to write a rule for the transformation described given the parent function. So my parent function is y is equal to f of x. We want to translate left 7 units and 3 units down. So our function would be y is equal to f of x, and going to the left, remember, is you're adding your k value on, so plus 7. And then going 3 units down means you're subtracting 3 from your function. So that would be our rule. Now number 2 says we just want a vertical translation 3 units down. So that would be y is equal to f of x. We're not doing any horizontal translation. We're just going 3 units down. So that's minus 3. And that's it. That's all you would need to do for numbers 1 and 2. A quick tip here is translation left. I just want to show you another way that you could write this is x minus a negative k, because technically we are going towards the negative values when we're doing a left translation. So that's why we get x plus the k. A horizontal translation is always going to be in terms of minus. So if you're subtracting a positive number, that means you're going towards the right, towards the positive values. But if you're subtracting a negative number, that means you're going towards the left, towards the negative values. All right, I wanted to make sure that I clarified that. Great, moving on. So the next one, the minimum point on the graph of the equation y is equal to f is this point here. We want the minimum point on the graph of the equation y is equal to 5x plus 5. Now this plus 5 is on the outside of our parentheses, so that would be a vertical translation up, which a vertical translation only affects our y value. All right, so that means that my x value is going to stay at -1, and now I'm going to add 5 to my y value, so I wind up with -1. Positive 2 as my new point. And that's all you would do in that situation. Now, if your plus 5 was on the inside of your parentheses, then that would affect your x value. All right, moving on to the next one. The graph below shows the function f of x. what graph would show the function f of x plus 2? Remember, f of x plus 2, when it's inside of parentheses, is the same as f of x minus a negative 2, because horizontal translations are in terms of a minus sign. So this means I'm going to be going 2 units towards the left, towards the negative values. So that would be graph B. All right, moving on. Describe the transformation for each given expression. So I have an f of x minus a 1 in parentheses. Remember the horizontal translations. Horizontal starts with the letter H, and so does the word hard. The horizontal translations are the hard ones to remember because it looks like a minus 1, meaning we would go 1 to the left. But in reality, horizontal translations are in terms of minus, so it's actually the opposite of what it looks like. So 1 to the right, and then the vertical translations are exactly what it looks like. We do include the operation on the vertical translations. That would be 2 up. So we are going to say that the function was translated 1 unit to the right and 2 units up. And so number 6, we have h of x, not the function f of x. Now we have the function h of x, which is fine. It means the same thing. But your h value, remember, your horizontal translation here is always in terms of minus. So this is the same thing as x minus a negative 7, and your vertical translation is exactly what it looks like. This is a plus 8, it's a positive 8. So this means I go 7 units to the left and 8 units up. So I'm going to say the function was translated 7 units to the left and 8 units up. All right. And that brings us to the end of lesson 1. So lesson 1, again, just to recap, these were the translations where we slid the graph to a different point on your graph. And vertical translations are exactly the way they look. If you do a plus k, that means you move up. If you do a minus k, that means you move down. Whereas horizontal translations are the hard ones to remember. A plus k means we're really actually going negative k units to the left. And a minus k really means we're going k units to the right towards the positive values. All right, so that's the end of our translations lesson. Now we're going to learn about reflections and dilations in the next one.